Material Science and Engineering at Penn State is one of the larger departments of material science in the country. By virtue of that, we are able to offer a full spectrum of research and teaching in the field of materials. We're strong in all aspects of materials: ceramics, metals, polymers, composites, semiconductors. That brings a certain uniqueness to the education of a Penn State graduate.
We've tried to basically give the students a very strong core into the fundamentals of material science and engineering, which are structure-property relationships. But because of the breadth and depth of the expertise in this department, they can choose to take courses that go towards interest, which brought them here in the first place. They could choose to focus in biomaterials, or they could choose to focus in energy. It really allows a student to make their own material science and engineering degree.
Being at Penn State, you get the large university feel where you are one in thousands of students. At the same time, you get the experience of the small college where everyone in the materials department knows you by name. I'm currently studying the corrosion of nuclear waste glass fibers with Dr. Pantano. I found out that he's studying glass and I'm really interested in glass. So I just set up a meeting with him, and about a week later he was showing me his labs. I think the most special thing I've done is get involved in glass blowing. I really enjoy doing it. It's very unique, and I don't think I'd have that experience anywhere else. A lot of the professors look for undergrads to do research for them, to give them a feel, and it helps you choose whether you want to go on to grad school or go into industry.
At any given time, I'll have 4 to 6 undergraduates working in my laboratory. Right now I have about 6. I bring both my research into my lectures for the undergraduates and my lectures into my research. The curriculum focuses on cutting-edge technology. We also run a very strong research experience for undergraduate programs. It's a summer science program where we bring in undergraduates from all over the United States, including Penn State, into our laboratories. We're at the cutting edge in terms of early detection of cancer and much more benign delivery of chemotherapeutics, as well as a host of new surgical instruments based on our ceramic powder processing.
We even take it beyond the department in this country. We have our own international internship program. We have relationships with 14 different universities in Europe and Asia, and we send our students there to join research groups for a semester and actually perform research. So it's not a study abroad, take classes, but it's actually going there with a research question in mind and then joining a research group and actually performing that research. So it's getting involved in the research enterprise, and it's global.
I've traveled to Germany with the department's International Internship in Materials Science program. That was great. I was in Germany for 7 months doing research at the Technical University of Darmstadt, where I was also doing some work with computational modeling, and provided a nice background for coming back to campus and starting my senior thesis.
Materials at Penn State is actually a very big enterprise. Not only do we have the Department of Material Science and Engineering, but we also have the Materials Research Institute. The Institute represents all of the faculty on campus that are working in the field of materials. The Institute brings the strength of community as well as the research facilities.
Penn State, we have great opportunities for high-level research in material science. Penn State has a long history in solving real-world problems in industry. We have over $100 million of research that the entire university does with companies per year. And we work with both large companies like General Electric and Dow Chemical Company, as well as small startup companies, either in State College or in Silicon Valley. And so I think that the research and the ideas here are flexible. We have a lot of unique capability.
The research that we are doing at Penn State in the area of low-dimensional materials is impacting the field of material science by providing new routes for the synthesis of low-dimensional materials, and also providing new insights into how these materials behave and ultimately how we can integrate them into devices. It feeds into other activities here at Penn State that are focused on the fabrication of devices. So there are faculty members in electrical engineering who are using the low-dimensional materials to fabricate transistors or other types of electronic devices.
The material science that we do at Penn State is really creating new opportunities and pushing new frontiers in material science. Our research that we do in our labs every day makes a big difference to new types of batteries, or new types of medical devices, or new types of structural steels that have better corrosion resistance, or are harder, or more ductile. And so I think that we both make a difference in real-world problems, but also we open up new ways to think about science and new ways to think about materials.